Okay, today we're going to do friction, but it's going to be a little bit different because the friction today is going to have angles involved. Now, every single problem is not the same. There are situations you cannot memorize like equations for different situations. So we're going to have situations where you have a block going on an inclined plane. When there's a block going on an inclined plane, the angle of the incline has to be factored into the problem. Okay? There's a lot of other things that you have to consider. So what are these things? Well, is the block being pushed up the incline or is it going down the incline? You have to also look at, is there even an incline? Because we're going to do some problems that involve angles where the block itself is not on an incline, but the force that's pushing or pulling it is at an angle. Okay? So the only difference between these problems and some of the other ones are, again, that there's an angle involved. But one of the things we have to remember, something key, is you don't necessarily have to have a force when something goes down an incline. So let me explain what I mean. Let's say I have a book, okay, and I put an object on that book. And I raise the angle of the book. Am I pushing or pulling the object down the incline? No. What happens is when the angle is large enough, that component of the weight is going to pull it down the incline. So number one is you have to realize there's not necessarily on an incline always going to be an applied force, a push or a pull. The key to doing these problems, just like any other problem, is your free body diagram. So this happens to be on an angle. So the key to doing any problem involving angles is first you draw your free body diagram. You show all the forces going in the direction in which they act. You always make positive the direction in which the block is moving. So your normal force acts perpendicular to the surfaces in contact. Your frictional force always acts opposite the direction of motion, and your weight acts down. So for this particular problem, just like we did before, we want to have all our forces going perpendicular and parallel to the surfaces in contact. So do you see here now how there's more than one force? Okay? So when we sum our forces, forces aren't necessarily going to be equal and opposite. When you sum your forces, you have to also say when the object is moving. If it's moving at a constant velocity, that means when you say summation of F is equal to ma, that means the acceleration is 0. There's many, many things to consider, and in these problems, you have to realize that every problem is different. So we can't memorize like the friction problems we did before. So another thing we're going to see is if I have a block like this, and I'm pulling with an applied force, do you see how this is not perpendicular and parallel to the surfaces in contact? So if I redrew this, and let's say I found the components of this force, FAX and FAY, when I wanted to redraw this, I would have here FAX, and then I would have FAY, but then don't forget, I'm going to have my frictional force, I'm going to have my force of weight, and then I'll draw it to the side, I'm going to have my normal force. Okay? So when you're summing forces, you see how things are not going to be equal and opposite? Okay? All right, let's look at one of the homework problems. So let's start with problem number 11. So this is, again, friction.